So in addition to calculating the voltage of capacitors, charges that are stored in capacitors, we can also calculate the actual energy in joules that a capacitor stores, because joules would be the work that would be delivered by that. So sometimes that's important if I want to calculate watts and whatnot. So here I have a diagram of a 12-volt battery connected to a capacitor, both a switch. So when I close the switch, gradually, okay, that voltage is going to increase on the capacitor, all right, and it's going to reach a maximum point. So how can I calculate the energy stored? So eventually 12 volts, potential difference across that capacitor would reach 12 volts as the charge gets applied to it. And it would store a total amount of charge. So how would I use these values to calculate the total energy? Well, let's just stop for a second and think. A volt is joules per coulomb, and charge is coulombs. So if I multiply these two axes together, I will get joules. So that's something we worked with a lot. When you take a voltage and you multiply it by the charge that's moving through that voltage, that would give you joules. So if I know the total charge, if I know the change in charge, the total charge, that from here to here would be the total charge stored on that capacitor, and I multiply it by the voltage, so the total charge multiplied by the voltage across, okay, that should technically give me the total energy, but you see here it's a triangle, all right, as it's ramping up. So the area under that is going to be 1/2 of 12 times the total charge. So a formula that we have for energy in a capacitor is going to be 1/2 my total charge that's stored times the voltage, 1/2 QV, all right? And remember, Q total is equal to C total times V. So another way of looking at this formula would be E is equal to 1/2 C total times V squared, okay? So both of these formulas are the same. So if they ever ask you to calculate the energy stored in a capacitor, you can do two things. You can find the total charge, multiply it by the voltage that's applied across the capacitor, multiply by 1/2, and that would give you the energy. Or you get the total capacitance, all right, multiplied by the voltage applied across the capacitor squared, okay, times 1/2 would give you the energy. So if I go back to that previous question that we looked at, okay, they can, in addition to asking the voltages, they can ask you what is the energy stored in each of these capacitors. Okay, so 1/2 C times V squared would give me the amount of joules that are stored there. C times V squared times 1/2, joules here. Pretty easy. So you just have to remember the formula 1/2 CV squared or 1/2 QV. Okay, those are one or the other, and you should have these in your data booklet. Sometimes they ask you to show how these equations are equivalent. You just have to remember to substitute, Q total is equal to CV, and then you get that formula.